Alright, so the beginning of chapter 7 is the introduction to trig identities. We're going to be simplifying trig expressions in this particular video, but if you're not in Canvas right now, you need to go back to Canvas because that's where all your notes are. So you need to know the reciprocal identities. Those you already know. You know that the reciprocal of sine, for example, is 1 over cosecant. Those you already know. The Pythagorean identities are very common. They're going to be very important. There's a video in Canvas that shows you where the Pythagorean identities come from. And then the even odd identities, there's also notes in Canvas that you need to get there. Alright, so this video is strictly simplifying trig expressions. We're not even going to look at trig identities yet. So all we're doing is simplifying the trig expressions. So there's different ways to do that. In general, I'm going to try to give you the best strategy that I know how to take care of these trig expressions and then later trig identities. So for now, we're going to write everything in terms of sine and cosine and then write in simplest form if possible. In other words, you don't want any fractions. You certainly don't want any complex fractions. Alright, so let's do some examples here. The first example I'm looking at is cosine of t times the cosecant of t. And especially when you're working in WebAssign, make sure you pay attention to whatever variable they're using. They change them up. So make sure if they give you, for example, the letter alpha, don't use a lowercase a and get it wrong. Use the alpha, Greek alpha that they give you. I'm not sure why they do that, but they do. Alright, so cosine of t times the cosecant of t. So I'm going to write everything in terms of sine and cosine. Well, cosine is already in terms of cosine, so I'm leaving that. And then we know cosecant, the reciprocal identity for that. So that's 1 over the sine of t. So I'm writing the reciprocal identity of that. Now we know with fractions we multiply straight across. So this is going to be the cosine of t over the sine of t, which that reciprocal identity I know is the cotangent of t. So that's my answer. Alright, going on. We've got the secant of x over the cosecant of x. So I'm writing everything in terms of sine and cosine. So secant of x, that reciprocal is 1 over cosine. We've got cosecant of x, which is 1 over sine. Alright, this is considered a complex fraction. It's a fraction within a fraction. You do not keep that, okay? We've got to simplify it even further. Now, there's 2 ways to solve a complex fraction. If you have one fraction, which I do, I have one fraction over one fraction, I'm just going to use the fact that I know this fraction bar means to divide. Alright, so I've got one fraction over one fraction or one fraction divided by a fraction. You know that when you divide fractions, you multiply by the reciprocal. So I'm going to multiply by the reciprocal of that bottom fraction. When I multiply straight across, numerator times numerator, I get sine of x over cosine of x, which all goes to the tangent of x. Okay, let's keep going. Here we've got the cotangent of theta over the cosecant of theta minus the sine of theta. Alright, so cotangent we're going to write in terms of sine and cosine, so that's cosine of theta over the sine of theta. That's my numerator. And my denominator, got cosecant, which we've already talked about several times. It's 1 over sine minus the sine of theta. Alright, so this first step here, I just got everything in terms of sine and cosine. Now I've got to simplify this as much as possible. I've got to get rid of all the fractions. Alright, so this is also a complex fraction because I've got more than one fraction within a fraction. And the easiest way to get rid of this complex fraction, now notice in the example above, I had one fraction over one fraction. Alright, so I could just divide, multiply by the reciprocal and be done. Here, I've got more than one fraction. If you've got more than one fraction in your complex fraction, the easiest way to deal with that is to multiply. Let me write that. Multiply every term by the LCD, the lowest common denominator. So I'm looking at every term here. I've got this fraction, I've got this fraction, and I've got that fraction, right? I'm going to multiply all three of those by the common denominator. And the common denominator of all three of those terms is the sine of theta. The sine of theta, right? This denominator is understood to be 1. So I'm going to multiply the top one by sine of theta. That means those sine of thetas cancel out. And I'm left with cosine up top. And then when I multiply the bottom one by sine of theta, those sines of thetas cancel out and I'm left with 1. And then when I multiply this by sine of theta, those are both on top, so those don't cancel out. I'm left with negative sine squared of theta. All right, so when I wrote everything in terms of sine and cosine, I ended up with a complex fraction. To get rid of the complex fraction, I multiplied everything by the common denominator, and that's where I am now. All right, now when we see something squared, hopefully you're thinking there's got to be something to do with the Pythagorean identity. Now remember that the Pythagorean identity is sine squared of theta plus cosine squared of theta equals 1. Which means if I subtracted sine squared of theta, took it over to the other side, I would get cosine squared of theta equals 1 minus sine squared of theta. Well, that's exactly what that is. All right, so I'm going to rewrite that, substitute in, and this is going to leave me with cosine of theta up top. That doesn't change. But on the bottom, I know that 1 minus sine squared of theta is equal to cosine squared of theta. All right, keep simplifying. We've got 1 cosine up top, 2 cosines on the bottom, so I can cancel one of those out, common factors, and that's going to leave me with 1 over cosine of theta. A fraction, we're not going to leave it as a fraction because we know that the reciprocal identity of cosine is secant. So all that simplified to secant of theta. Okay, let's keep going. All right, here we've got sine to the 4th of x minus cosine to the 4th of x plus cosine squared of x. Now, when you run into something squared, you should naturally think, okay, what am I going to do with this? I hopefully can do something with the Pythagorean identity. In this case, it's to the 4th, so we need to figure out what we can do to simplify that. Now, if I look at this, this is the difference of perfect squares. Remember the difference of perfect squares. Let me give you a easier example. Say if I give you x squared minus 4. How could you factor that? Remember that is x plus 2 times x minus 2. That's a perfect square. That's a perfect square. You have to be subtracting because when you FOIL that back out, those middle terms have to cancel out. This is also the difference of perfect squares. So I can factor this. So I'm going to factor this just like I did x squared minus 4. This is going to be sine squared times sine squared of x plus cosine squared of x minus cosine squared of x. All right, that's just factoring the difference of perfect squares. So that's what I end up with. And then I still had that last term, which is cosine squared of x. All right, now if you look, do we see anything familiar to us? Hopefully you recognize this. This is going to be probably our favorite thing because we know that sine squared of x plus cosine squared of x equals 1. So I can substitute that 1 in there. I'm still left with sine squared of x minus cosine squared of x plus cosine squared of x. Now I'm going to clean this up and get rid of the parentheses. You're distributing a 1, which isn't changing anything. So you've got sine squared of x minus cosine squared of x plus cosine squared of x. Those are opposites, those add out. And so all of this simplified to sine squared of x. Okay, let's keep going. We got a couple more we're going to do. We've got the secant of x minus cosine of x over tangent of x. Everything in terms of sine and cosine. So we've got 1 over secant of x. Oops, not secant. That's what that is. 1 over cosine of x minus cosine of x all over sine of x over cosine of x. Tangent is sine over cosine. All right, hopefully you're recognizing this as a complex fraction. How do we get rid of a complex fraction that is more than one term over one term? We've got 3 terms here, so we're going to multiply all 3 of these terms by the common denominator, which in this case is the cosine of x. When I multiply that first term by the cosine of x, I've got 1 on top, 1 on the bottom. That cancels out. That leaves me with 1. Then I've got cosine squared of x times cosine squared of x, which is, cosine of x times the cosine of x, which is cosine squared of x, all over, then I've got those canceling out again, all over sine of x. 1 minus the cosine squared of x. Go back to your Pythagorean theorem. If you subtract cosine squared of x from both sides, you'll see that this is the sine squared of x. And I can cancel one of those out, common factors, and I'm left with sine of x on top here, which is my final answer. Okay, let's do one more. 1 plus sine of u over cosine of u plus cosine of u over 1 plus sine of u. All right, so we've got this fractions. You know, when you add fractions, you have to have a common denominator. The common denominator in this case is going to be the product of all the factors. So it's going to be the cosine of u times 1 plus the sine of u. All right, I have to use all those factors. All right, so going back to what you know about adding fractions. In this first fraction, I have cosine of u on the bottom, but I need the 1 plus sine of u, which means I'm going to have to multiply by 1 plus sine of u over 1 plus sine of u, right? Because that gives me my common denominator here on the bottom. That's what I needed. And really that's multiplying by 1, because anything over itself is 1. So I'm going to multiply that first fraction by 1 plus the sine of u. The second fraction, what am I missing? I'm missing that cosine of u. So I'm going to multiply the top and the bottom by the cosine of u. All right. So in this first fraction, let's multiply it out. We've got 1 plus the sine of u times 1 plus the sine of u, because I had to multiply that times the numerator. In the second fraction, I've got cosine of u times the cosine of u, or cosine squared of u, and all of that is over my common denominator, which is the cosine of u times 1 plus the sine of u. All right, now your intuition may be wanting to cancel one of those 1 plus sine of u's out, but you can't. You can only cancel if you're multiplying. And see, we're adding here, so I can't do that yet. All right, so let's multiply this out and see what happens. So I'm going to FOIL this out. I'm going to distribute. I'm going to do my first outside, inside, last thing through the FOIL thing here. So we've got 1 plus sine of u plus the sine of u plus sine squared of u. That was my FOIL. And then I've got plus cosine squared of u. That was still left over from the end of that. All right, so I multiplied that out. It stays over my common denominator. All right, so let's put our like terms together and clean this up. Up here, I've got these 2 like terms. So that's 1 plus 2 times the sine of u plus sine squared of u plus cosine squared of u all over my common denominator. Do you recognize anything that we can do to simplify this? I see my favorite, sine squared plus cosine squared. We know that is 1. So let's substitute in that. We've got 1 plus 1. So we've got 2 plus 2 times the sine of u all over the cosine of u times 1 plus the sine of u. Alright, one more thing we can do to simplify this. Notice I have a 2 in both of those terms, so I could factor out a 2. When I factor out a 2, I'm left with 1 plus the sine of u all over the cosine of u times 1 plus the sine of u. Now I am multiplying, so I can cancel factors. Those 2 factors cancel. I'm left with 2 over the cosine of u. I don't want to leave this as a fraction. Remember, 1 over the cosine of u. This would be like 2 times 1 over the cosine of u. We know that is secant. So all that is going to equal 2 times the secant of u.